I'm a junior researcher at the Institute for R&D in Microtechnologies from Bucharest, at the Laboratory of Nanobiotechnologies. I would like to present you today the results we have on 3D inorganic nanostructure substrate for applications in genetics. First, because we are a multidisciplinary laboratory, I want to show you fast some of our research directions. In nanomedicine, we have some prior results on drug delivery systems, and now we are more focused on the development of diagnostic tools for in vitro diagnostic more. We have also some results in the nanotoxicology domain in the framework of FP7 NanoValid project. Other research directions include the synthesis of functional nanomaterials and advanced characterization methods, and also the design and fabrications of nano-micro-electromechanical systems. Regarding the nanostructure substrates, our vision is to develop such a system for microarray biochips and for future integration into a lab-on-a-chip device to address the need of an improved diagnostic technology. Thus, the missions are to obtain the appropriate 3D nanoarchitecture for the second-base substrate and to enhance the molecular diagnostics of various types of cancer. We try to address the following medical issues. First is to define the molecular signature of human cancers by detecting the single-base mismatches. And to go towards the development of a personalized approach to patient care. And second, to determine the prevalence of HPVs in order to determine the risk associated with infections of a particular type. And we try to address nanotechnology for designing the diagnostic tool with the accent put on reproducibility. In order to recognize the single nucleotide polymorphism without artifacts and to identify specific HPV types from their latent form of infection. In the clinical practice, the current solution for SNP assays include the PCR coupled with restriction fragment length polymorphism, next generation sequencing techniques, high-resolution melting, and of course commercial microarray chips, which come, every type of method comes with advantages and some disadvantages. For HPV genotyping, the detection methods are PCR-based systems and hybrid capture assay. Our solution is nanostructure surface for the multiplexed single nucleotide polymorphism and HPV types detection. In the SEM image is presented the surface of the silicon nanowires obtained by a top-down method, metal-assisted chemical etching. Our solution has a chance to work because the nano-configured substrate has anti-reflective properties, and this greatly improves the signal-to-noise ratio, and also the high surface-to-volume area improves the detection sensitivity of mismatches with pathological significance. Here are shown some hybridization results on KRAS sequences with the red spots, and hybridization of BRCA1 sequences on the nanostructure support. Here are shown the BRCA1 selected synthetic oligonucleotides, perfect mesh sequence, and three types of mismatches in the same place, in the middle of the sequence. The student's t-test has shown that the configure the substrate improves the detection compared with commercial glass support. Also, the signal to noise ratio calculations show a twofold improvement on the nanostructured substrate due to the optical properties. This preclinical testing allowed us to reach the technological readiness level 3. We want to go towards analyzing real samples to validate the results by enabling the dual detection of the signal, let it be fluorescent or electrochemical, and towards integrating this substrate into a lab-on-chip device. Here I present some of the equipments and the contacts of my colleagues which work on them. These are my colleagues from the Laboratory of Nanobiotechnology. We are a multidisciplinary team, and with various level of expertise. Thank you.